right, ladies and gentlemen, in front of you, you have the post-test preview. Runs parallel to the post-test itself, so if you know what you're doing on this, you know what you'll be doing on the post. So, here we go. Jennifer solved the following equation incorrectly. Tell what the error is and solve the problem correctly. Okay? So I kind of start looking through, and I'm like, all right, so we distribute first. That'd be 1/3. Oh. There's my problem. Didn't distribute here. So, forgot to distribute to the +6, or some way of writing it. You also can show me here in the correct work when you're like, well, that'd be 1/3 x, and then that'd be 1/3 of 6 is 2. Now, I'm sure somebody's out there going, well, what if I do it completely different? What if I multiply both sides by the reciprocal first? Could I do that? As long as you can get to the right answer and you show me, that's fine. Okay, but we still got to determine what her error was and try to fix that. So we go ahead. We get that situated, and in my way of doing it, I'd get to my solution that way. Okay? Like I said, multiple ways to fix the error, but that is the error, and you need to be able to describe that. So let's see. Solve and graph the found inequality. Again, yours should have been adjusted. My apologies. That was supposed to be a positive too. I almost messed that up. So here, before I start dividing and conquering, I need to make sure my absolute value is on a side by itself. Because if it's not, when I split this, it's not going to work correctly. So once I get to this part, now I'm ready to get my, again, two inequalities. Why? Because the absolute value, you're coming in from both sides of your value. So the first one I leave this way. Since the absolute value is greater than, it's an or statement, which gives us some clues about what the graph would look like. And then again, remember when I get to the second one, I'm flipping the arrow. I'm changing the sign of my solution. I'm not messing with what's inside the absolute value at all. Go ahead and solve this, because again, some of you might be thinking already, woo, he's talking fast. But remember, this is something you should have situated already. You should have tried something. So you're really just kind of watching to see what I'm up to here. Not hopefully just writing down everything as fast as you can and spoon feeding all this. So there's my inequality solution. Again, I reminded myself before what this should look like, with it being an or statement. They should be going out. But just to make sure, x is greater than or equal to 1. X is less than or equal to -13. I see what I'm supposed to see. And my interval notation would match that, including my brackets on my numbers. Not too bad. Not too bad at all. So as we keep rolling here, solve using square roots. All right. Isolate my squared term first. Now I get to here. Here comes the moment of truth. Two things I need to remember. Okay, first thing, whenever I'm solving a quadratic, there would be two solutions, plus minus. Secondly, if said radical is able to be broken down, with one of my factors being a perfect square, I need to do that. And then I'm set. Okay? And again, at this point with this type of stuff, as much as we've seen it, you should be rolling almost as quick as I do here. And if not, you need to kind of go back, look through this again, maybe make yourself up a problem or two, or maybe go back and do some of that homework that didn't get done. I'm just saying during the semester. So as we flip the page here, okay, using tech, find the zeros to two decimal places. Okay. So normally here, just a second. Let's darken that up a little bit. Normally with this, we go to our y equals, go to x squared minus x minus 9. And this is where we do our second trace and go to our 0. This is going to be the fastest way, even though it looks like, oh, it's okay, I can still do it this way. Because again, we're going to use our left and right arrow keys. Let me get this up a little bit. To get as close as we can to the x-axis. And then since it's a left bound we're looking for, we're going to go left, 1, 2, 3. Hit enter, get our boundary. We're going to go right 3 to get back where we started. And 3 more to the right, because I'm looking for my right bound. And then for the guess, I don't have to really do anything. I just want to make sure that my boundaries are set back in. And we've got one boundary. And then we repeat the process again. Now, some of you may be wondering, especially with what we've been doing lately, hey, if I forgot how to do this, could I use the quadratic formula? Technically, you could. Okay, it's a speed issue here that we really do want you to use the technology, but yeah, that kind of would be an option if you were in desperate times, and sometimes desperate times call for desperate measures. Let me do that for my other one. Okay, so second trace, close to the x-axis, 3 to the left, 6 to the right, boom. All right. 5 and 6 are our next favorites functions. Okay, find f of x minus g of x. All right, so f of x minus g of x. Now don't leave it that way. Distribute your negative through. So that doesn't mess with my f of x at all. Make sure that negative gets all the way through. And now I'm just going to combine like terms, which in some cases isn't very much at all, and get to my answer. Okay. If it's a composition, okay, G is being plugged into F, second being plugged into first. So this is going to be f of x minus 2. What's that mean? It means when I start writing my f function, when I get to x, I replace it with what's in the parentheses. Now please, okay, I'm begging. Just showed some of you guys after the last quiz how much damage you can do to me by thinking that x minus 2 squared is x squared plus 4. Please, I beg of you, don't be that person, okay? Go to the side here a little bit if you need. Work it out. Find that middle term. Don't forget about it. Okay, it's not just x squared and plus 4. Oh no. There's the middle term. And don't forget about the plus 4 that was there already. So this is just the simplify. And now to get to the actual solution, distribute my 3 through. Here I get plus 12, but then I got another plus 4 outside. No, it is not time to go anywhere. If you're at home, it is not time to go anywhere. You have got more of this to look at. Okay. Consider the function. Find the inverse. Again, f of x is a fancy way of saying y equals. So we switch x and y, and we're solving for y. So we're going to do opposites. Oops, I'm a little ahead of myself here. Now divide by 3. And again, noticing that I'm going to have to graph it down below. Could I just write it as x plus 9 over 3? Sure. Is that going to be the easiest to graph? Probably not. So remember, I can break this into 2 separate fractions. 1 over 3 I can't do much with. 9 over 3 I can, though. So I would prefer to see it this way. Because then we get down here when it says graph the original function and the inverse. Okay, there's my original function. Plot my y-intercept. Remember slope. 1, 2, 3, 1. 1, 2, 3, 1. We just kind of go dot crazy here. So we get a nice, accurate line. So I'm just going to call that y. I guess I could call it f of x. For my other one, again, 1/3 x plus 3. There's my 3. Rise over run. Okay, it's those little things, especially on a test like this. So up 1 and right 3. And right. Count, Harty. 1, 2, 3, 3. And what I should be seeing, remember, these are reflecting over the line y equals x. Now, you don't have to put the line y equals x in, okay? But if it kind of helps remind you, oh yeah, if I folded over that, I'd get a reflection. But again, switch x and y, solve for y when we're looking for an inverse. Okay, state the domain and range, determine if it's a function. Notice, dot, arrow, that matters. Okay, domain, I'm going forever to the left because of the arrow. I'm not going forever to the right. I'm only going to 5. Oops, to 5. Okay. My range, down forever, not up forever. Highest point y value, 2. Is it a function? Ooh, now be careful. Not asking if it's an inverse. Don't get sucked in. Vertical line test. If I draw a vertical line through here, am I ever going to get 2 points instead of 1? Nope, so I'm good. Why or why not a function? Passes vertical line test. If it asked you why or not is there an inverse, then it's horizontal. Just saying. Don't cookie cutter this review and think it's going to be the exact same question. I could tweak things a little, so think about it. All right. Maya shoots an arrow upward. The height of the arrow is given by the equation. Complete the table below to show the heights at the given times. Okay, again, there's an easy way and there's a hard way. We're going to try the easy way. The easy way is to get into y equals. Type this bugger into the calculator. Pull the chart. Okay, this time in seconds is my x value. This height in feet, still not time to go nowhere, is my y. So all I want, plug in 3 and 4 and 5. Okay. Find the average rate of change in height from t equals 3 to t equals 4. Average rate of change. Fancy way of saying the slope of the line. Okay, we'll say air quote slope. My apologies. Because this isn't going to be linear. So what does that mean? It means we're going to take the changes in our y values over the changes in our x values. So my x values are 3 and 4. You could do it the other way too, but here's the kicker. Whichever x value or t value here you start with, you need to start with the same y value, the corresponding y value. So if you would have done 4 minus 3 here, you'd have needed to have done 66 minus 98. Okay, because it matters because it's going to change the sign of my answer. Okay, and a sign matters when we're looking at slope. See if something's increasing or decreasing. How long does it take the arrow to reach its maximum height? Okay, maximum height. X value of my vertex. You have options. To me, the simplest way, though, and the fastest, if I'm looking for the x value of the vertex, I know how to do that. It's negative b over 2a. There's my b, so negative b over 2a. Now, since we're normal, we're human beings, we like to speak in, what's good for what we're talking about. If you're talking about like the speed that something's happening, you're not going to go up to somebody and say, hi, it's going to take 30 seconds. 80 over 32 seconds. Nobody does that. Oh, can't even see the number. That's kind of, okay. 2.5 seconds. Seriously, that's it. Okay? Janine graphed the following absolute value function incorrectly. What did she do wrong? Well, let's see here. What should my vertex be? My vertex should be at 3, 2. Oh, her vertex is at 3, negative 2. Wrong vertex. Y value. Ooh, the more specific we get, the better. So instead, we're going to go to 3, 2. And then since my air quote slope is just 1, it's just up 1 and over 1 in each direction. Okay, not a parabola. Don't try doing the 1, 3, 5. That would get you a different picture. These are just going to be V-shapes. And I noticed that right away. And actually, if you look, you can probably see that Janine did something else wrong now that I noticed. Because look at her air quote slope. Up 2 and over 1. Her slope is 2? You can even say that. So it's multiple things she did wrong. So you could put either of those and be absolutely correct. Okay. So always take that look. Or maybe you even do it yourself and then look at it to try and see where that error is going to be. Into the back we come, and yes, this is the end. This is how long yours is going to be. Graph the following polynomial function, identify any zero, show the end behavior. Okay, we are going to attempt to keep life hopefully simple. We'll see if we're fortunate. It's 3x squared minus 10. Oh dear, that's not keeping life simple. Let's try that again. X to the third, bring it back down, plus 3x squared minus 10. That's better. Okay. When we're going to graph, we are going to be polite to the person graphing this. And when it says graph, don't just put some goofy sketch hit graph and kind of half-heartedly do it. Find some points that you can actually plot on here and plot the points. Now, some of you may start looking at this and go, wow, that's not many points. Okay, let's look around a little bit here. Oh, now if I head back the other way, got some more. Well, let's look at the graph now. Let's see if that helps me to see. Okay, so kind of looking at the graph and the points that I have here. Looks like I can go up. Wow, it's kind of bad. Okay, at least I have as many points as I can on the graph to make this try to look accurate. But here's where I want you to save yourself some time and stress. Notice there's 3 blanks for 3 zeros. Okay, I see that on here. Instead of doing second, trace, 2, and trapping all of them, which you could, and that's fine, always double check something. If you look at the chart, always check to see, does y equal 0? If you find places y equals 0, steal them off the chart. Why are we going to do work if we don't have to? Now, will you always get fortunate and get all of them this way? No. If you don't, you're still going to trap them like we have before. But shoot, if you can get 1 or 2 this way, I'm just saying. I take the freebies when I can get them. And then my end behavior, and we talked about this before, as x goes to negative infinity is over here, so that's to the left, what direction is my y going? Is it going up or down? Well, it's going down. So it goes to negative infinity. Well, as x heads to positive infinity, as x goes to the right, what direction is the arrow going? It's going up or to positive infinity. Okay, keep it simple. And finally, factor the following quadratic equation. Okay, I can't say this enough. Golden rule, people. Come on now. Do not slide and divide right away. Do not factor right away. If something goes into all 3, get it out. Otherwise, you're going to get to the end and you're not going to have completely factored. Once that 3 is out, we factor what's left. Thankfully, it's all pluses. multiply to 10, add to 7. That, ladies and gentlemen, is my fully factored form that we'd be looking for. Now, will there be partial credit on this, post-test, where if you didn't do that, let's say you ended up with 3x plus 15x plus 2, which would still work, yes, you'd still get some credit. You just wouldn't get all of it. Pair them up and conquer. 3x squared, get the biggest common factor. Always double check to see if you distribute, if you get the same thing back. Let's see here. I think it's plus 2. Let's see. 2x. 2 times negative 7. And again, that's the key. Do I have that same set of parentheses? If I do, I pair the greatest common factors. And I keep the common pair that I had. Oh, 2 to go. AJ was asked to show the complete factorization of the following polynomial. Now that's interesting. AJ became Billy. I wonder if that's AJ's nickname. I don't even know. Okay. But back to our focus here. Has Billy completely factored this? No. If not, what would that look like? Now, this is one of those situations. Since they didn't ask me to tell what Billy's error is, I'm just going to do it by myself. So I'm looking here and I'm like, okay, they both got an x. They both are divisible by 8. So I already see that Billy's is off. Let's see, x squared, because 1 plus 2 is 3. That would have been fun. And then 72 divided by 8 is 9. Don't write that as your answer. What? Billy didn't go any further? Well, I don't care. Billy doesn't even know if his name's Billy or AJ at this point, so we can't really trust him. So here, difference is squares. And you got to know, I'm going to do something crazy like that. Completely factor it. Even if you go brain dead, at least get to this part. Get some kind of credit. And finally, completing the square. Yes. I get to partially sing. Here we go. Okay, when we're doing vertex form, remember, vertex form, this is what we want it to look like at the end. So to get there, we're going to add a blank to the y side. We're going to group our x's together with a blank because, remember, we only do one blank per side. So one with the y, one with the x. How do I get the blank? This is where you've got to have your flashback to DJ Pi. We're going to have b. We're going to square half b. Now it sounds like a country version of it. That's even worse. Pen not working. We got to add it here. We got to add it there. Now this is where the song changes a little bit because we're not solving, we're just trying to get it into vertex form. Get your binomial, either a half b or what you had in your parentheses if you did side work. And when you go to do this last step to get y by itself and you minus the 9, don't mess with the parentheses. That would be not right. And if I were asked to find the vertex, even though I wasn't, opposite of h and k. Okay, ladies and gentlemen, this is nearly, a carbon copy of the post-test portion of your final. Check this stuff over, go back over some things if you need to, ask some questions, and be ready so we can have a good final exam.